Good evening, everyone. Welcome to another exciting session proudly organized by the Microsoft Student Club of Wellassa University. I am Masada and I am delighted to be your host for this evening. Today's session dives into a topic that sits the intersection of two game-changing technologies, big data and artificial intelligence. The session titled Big Data in the Age of AI. From how data is collected and processed to how AI models are trained and improved, big data plays a crucial role. And tonight, we are incredibly lucky to have someone who works hands on in this space sharing real world insight with us. Now, let's welcome the person we all have been waiting for, our distinguished guest speaker, Mr. Anjana Dodampe. Mr. Dodampe is a passionate data professional, AI/ML enthusiast, a Microsoft Learn student ambassador, having completed both alpha and beta milestones, and a committed IEEE volunteer who has made remarkable impact in Sri Lanka's tech community. He is currently a senior software engineer at the London Stock Exchange Group, where he contributes to building large-scale data-driven software systems used globally in financial markets. His journey began at LSEG as an intern. Through consistent dedication and performance, he rose to become a senior engineer in under 4 years, a clear sign of his technical excellence and drive. Anjana is a graduate of University of Colombo School of Computing, holding bachelor's degree in computer science. He is also a designated finalist recognized for creative problem solving with Team Queen Riots. But more than titles and roles, what defines him is his love for learning and his commitment to growth and his enthusiasm to empower other tech. Tonight, Mr. Dodampe will guide us through the evolving landscape of big data in age of AI and how we as students and future professionals can prepare to thrive in this dynamic field. So without further ado, let's give a warm welcome to Mr. Anjana Dodampe. Sir, the stage is yours.
Thank you very much for that lovely introduction. So first thing, let me share my screen. I hope it's visible. So first thing first, I go on. So let me walk you through today's session. Let me start it with this video to get our stuff going.
At Microsoft, we're optimistic about the future. Artificial intelligence changes the way we can use data to make new discoveries and improve people's lives. As a data scientist, it has always been my dream to apply technology for the benefit of humanity. I've been fortunate to do this work at Microsoft AI for Good Lab, where for years we have partnered with organizations and leading experts across North America, South America, and Africa. We're using AI to update maps of communities around the world to help ensure they receive the essential resources they need, to understand where people and structures are located so we can better prepare for and respond to natural disasters. We can even use AI to assist doctors in early diagnosis of diseases to help people live longer, healthier lives. In some cases, AI isn't just a solution, but is the only solution we have. Though we have learned and accomplished so much, there are still so many more opportunities to improve the lives of people around the world. We hope you join us in using AI for good.
I think from that video you may have gained an insight into our today's session, how AI is changing the world. So data is the fuel that powers AI. So let's discuss this with this analogy. Let's say your supercar requires fuel to drive forward. So if AI is your supercar, then data is the fuel. So this is a symbiotic relationship. Big data provides the fuel for AI, and the AI provides intelligence to extract values from this big data. So that's where we are going to dive in. big data in the age of AI. So I'm Anjana Dodampe. I think you have got a nice introduction at the beginning. So let me follow you through today's lineup. So today, first we will discuss about introduction to big data, and we will talk about important big data tools in this landscape: Apache Hadoop, Apache Spark, Apache Airflow, and how these. Then we will talk about how these services we integrate in real-world application through Azure. So to start things off, let's see what is actually big data. So what is big data? So normally we refer big data into extremely large and diverse collection of structured, unstructured, and semi-structured data that continuously grow exponentially over time. So these datasets are so huge, and they are complex in volume, velocity, variety, and the traditional database data management systems, they cannot handle this kind of data. So that's the main challenge we come across when it comes to big data. So if we compare small data and big data, so we can categorize small data as the data is small enough for human inference, and this data is accumulated slowly, and they are relatively consistent and structured like JSON format and XML files, and these are mostly located in storage systems within enterprise data centers. So when we take big data is huge volumes, and they are structured and semi-structured, or sometimes they may be unstructured. And we need to process this data in order to generate insight. And also, this data arrives continuously at a high speed from multiple sources. And we can take diverse formats of big data. And this big data is distributed across cloud and server farms. So if we talk about big data lifecycle, we can see first, as the first stage of this lifecycle, we have the business case. That's where the real problem we are going to tackle comes. Then what we are doing is, after identifying the problem, we are collecting data for that. That is what happening in the data collection phase. Then we model that data, and we process data, and then we visualize data to derive valuable insights. So when we come to data volumes, personally we get to deal with data in gigabyte scale. In day-to-day life, we get to deal with data in gigabyte, sometimes maybe in terabyte scale. But when we come to big data is exceeding all those, from petabytes to exabytes to and zettabytes to yottabyte. So that the volume is growing exponentially. So when it comes to big data, we can identify several characteristics of big data. We, we can denote this as the 4 V's of big data. They are velocity, volume, variety, and veracity. So let's discuss about the first characteristic, velocity. So this velocity is the data that is generated fast, and the processes that never stops. This velocity represents various attributes like batch attributes, close to real-time data, and streaming. And we have to consider whether these data are coming as batch or close to real-time or streaming. So the main drivers of this velocity is the improved connectivity and hardware, rapid response time, and pre-calculated analysis. So when it comes to volume, it represents the scale of data. That means the increased amount of stored data. So when we consider about the attributes of this volume, we can identify the storage sizes. That means petabytes, exabyte, and zetta. So when we take the drivers of this volume, they are the increasing data sources and the higher resolution sensors and the scalable infrastructure. The next characteristic is variety. Variety means the data that comes from machines, people and processes. Basically that means data coming from different sources. They can be structured, semi-structured and unstructured. So we can identify structure, complexity and origin as attributes of this variety. The main drivers of this variety are mobile technologies, scalable infrastructure, resilience, fault recovery, efficient storage and retrieval. Then here comes the next characteristic, veracity. Veracity means the quality, origin and the conformity of facts. That means the accuracy of data. So these data comes from people and processes. So if we consider about the attributes, we can identify consistency and completeness, integrity, ambiguity. And when it comes to drivers, we can identify cost and traceability, robust ingestion, and ETL mechanisms. Next comes the important part, the fifth V of big data. Actually, that is the most important V of big data. It is the value. As I explained earlier, big data refers to extremely large and diverse collection of data from different sources. So if we take in today's day-to-day life, we can identify so many use cases where this big data is found. So they are mainly found in the recommendation engines. So they analyze data from product searches and they consider past orders, and all this data is used in the recommendation engines. So the major companies like Amazon, Netflix, Google, Spotify use these recommendation engines at their work. So let me walk you through this video as well.
Is the symbiotic relationship between the human and machine that brings the magic of AI to medicine in a meaningful way.
Now we have the tools to make a huge difference to human life.
Cancer research is increasingly powered by data.
Those data remain siloed across institutions.
We're creating a data ecosystem that allows people to share data and making sure that we're doing that in a way that still maintains the privacy of the patients.
With the power of AI, we can go after the unknown. And I can guarantee that we'll find something that nobody expected.
Sutherland syndrome scares every mother and father, and it is a problem we have to change. The collaboration with Microsoft AI for Health will help to start this next step of our discovery. Our data show very convincingly clear correlation between smoking and SIDS, and just changing behavior can save children's lives. You cannot measure the benefit of that.
It's a sad day when the patient comes in and I can't impact them.
Through AI for Health, we will be building an AI solution that can autonomously diagnose diabetic retinopathy.
With the portable camera, I can take healthcare to the patients who would not be able to come to us.
I want you to look right here.
Going forward, we can address the 500 million patients that are out there and disrupt this disease. AI for Health and IRIS together can have that impact.
Today, there are 200,000 leprosy patients diagnosed every year. If you catch it in the stage of a skin lesion, you can cure the person. We are teaching an AI algorithm to recognize leprosy in an image of a skin lesion.
With AI, we can help patients help themselves to get to the right experts at the right time. If you can help a child to not lose their fingers, that means everything.
Innovation comes from bringing different perspectives together. And what an amazing partnership this is for all of us.
When you see that you can make a big impact on somebody's life, that's the greatest thing ever.
We can help eliminate the oldest disease known to man, then make history. That's how we want to contribute to the world.
So from that video, you have seen how big data is impacting to improve the lives of people. So as you see in the video as well, we can see how today virtual personal assistants help us in our day-to-day life. So likewise, we have a competitive advantage when it comes to big data because the data is the new oil, as stated by Clive Humby, the chief data scientist of StarCount. So without big data, you are blind and deaf and in the middle of a freeway. That's how Jeffrey Moore has stated the significance of this big data. So when we consider about the key points, we can see the powerful machine learning algorithms drive business decisions that increases efficiency and earn them so many profits, as well as data scientists and big data engineers bring this value to companies. So this is the current, if we take today's data engineering landscape, we can identify so many tools. So there are numerous kind of tools for different stages of data engineering. So when it comes to big data tools, so it's important to understand them through history. So let me walk you through historical side of it as well. So in 1940s, the ENIAC, that means electronic numerical integrated and computer, that laid the foundation for the modern computing. So in 1960s to 1990s, IBM's hierarchical model streamlined data organizations, but it had limitations. So when it comes to 1990s, the explosion of data collection with the rise of internet and tracking technologies took place. And in 2000s, Google introduced this MapReduce framework, which revolutionized the scalable data processing. And mid-2000s, Hadoop emerged as an open source implementation of this MapReduce, which opened new doors in the big data domain. And 2010s, Spark introduced memory utilizations for faster processing and flexibility. So today we can see so many advancements in Spark. Today in 2020s, we could see Spark 3.0. Today we have Spark 4.0 as well. So that's how big data evolved through the history. Now let's discuss about the foundation of big data, the Apache Hadoop. So why Hadoop? As I explained in earlier, when it comes to small data, we have to process around 1 GB or within the known limits. But when it comes to big data, we have so many massive volumes of data. So why Hadoop? So Hadoop came as a solution to this problem. So this was designed to help organizations to manage terabytes of data. That's how Hadoop came to the rescue in this big data world. So what is actually Hadoop? Hadoop is an open source programs and procedures. So as I mentioned earlier, this is used for processing large amounts of data, and Hadoop servers run applications on clusters, and they handle parallel jobs and processes. So I think you may have known the cluster is a collection of computer nodes working together to perform tasks. So this is how Hadoop evolved. So in 1999, Apache Software Foundation established. Then 2002, Nuts web search engine created. Then 2006, Nuts was divided into a web crawler and a distributed system. And by 2008, Yahoo released this Hadoop as an open source project. So how does Hadoop work? So when it comes to Hadoop, we can identify three main components: HDFS, that means Hadoop Distributed File System. Then we have MapReduce component and YARN. So this HDFS is the distributed file system that handles and stores large data. So this scales a single Hadoop cluster into as much as 1,000 clusters. So when it comes to MapReduce, it's a distributed processing programming model that is used for processing large-scale data sets. So it basically breaks the processing into two phases as map and reduce. So I will explain it in down the line. So when it comes to Hadoop, we can identify several advantages that mean cost and minimum network traffic. It is highly optimized data processing by keeping computation close to where the data is stored, and we have the high throughput that enables fast processing of large-scale data by distributing tasks across multiple nodes. Then it provides the agility of fault tolerance, ensures reliability by replicating data across multiple nodes. So if one node fails, another takes over. And also when it comes to speed, parallel processing allows it to work faster than traditional systems. And also it offers the flexibility of various type of data, whether they can be structured or unstructured, that make them highly adaptable to this system. So that are the main advantages of Hadoop. So when it comes to Hadoop, we come across several challenges. They are processing transaction. So Hadoop is actually optimized for batch processing, meaning it struggles with transactions heavy tasks requiring frequent real-time data access. And also when we work with uh, the work that cannot be parallelized, Hadoop relies on this distributed computing. So if we can't break a task into smaller or parallel processes, it may be inefficient. And also dependencies in data. When data is highly interconnected and it requires sequential processing, Hadoop's distributed nature can make it handling such dependencies much complex when compared to other available solutions. And also when we consider about the low latency data access, Hadoop is not ideal for real-time analytics because it primarily works with large datasets rather than delivering instant responses. And also it processing lots of small files. Hadoop is designed for massive files, but handling numerous small files creates overhead and it slows down the performances. And also it undertakes intensive calculations with little data. So if a task requires heavy computation, but it involves small data volumes, Hadoop may be overkill and inefficient. So that's where this MapReduce comes in. So programming model used in Hadoop for processing big data is this MapReduce, and this is a processing technique for distributed computing. So this consists of map task and a reduce task, and it can be coded in many programming languages like Java, Python, C++, Ruby, and R. So why do we need to use this MapReduce? So this MapReduce is a powerful programming model. As I mentioned earlier, it is used in this distributed computing. So it works by breaking down large data sets into smaller chunks. That is how we call it as map phase. And they process them in parallel across multiple nodes. And in the reduce phase, they combine this result more efficiently. So why this is useful is because when it comes to parallel computing, it distributes tasks across multiple machines. So this speed up the data processing. And also it enables task division. Instead of working on an entire dataset at once, MapReduce breaks it into small parts of processing and handling different data types. And also it can process structured data and unstructured formats like videos and images as well. And also it supports multi-language support, as I mentioned earlier. And also it is a great platform for analysis and data warehousing. It analytics and it is essential business intelligence and decision making. So this is the MapReduce, how actually MapReduce works. So actually MapReduce is the heart of Hadoop. So that's what enabled Hadoop this distributed data processing. So you can see how in the map phase, it assigns each here. If we take this dataset, we can say it split dataset into three components. Then it maps the exact count of the available data, and then in the next phase it shuffles. And in the reduce phase, as you can see clearly in the diagram, it has shortlisted the available listing ones, and combining the result obtained from this reduce phase, it shows the final result. So this is the actual under the hood workings of this MapReduce function. So now let's talk about the powerhouse of parallel processing, Apache Spark. So Apache Spark is also an open source software tool which is widely used in big data processing. So this is an in-memory application framework. So it is widely used in big data processing. So what is actually distributed computing? I have been talking about this in the previous slide as well. So I think I have already mentioned it. It is a group or a cluster of computers that working together to appear as one system to the end user. So when we take Apache Spark attributes, this Apache Spark is predominantly written in Scala, and it runs on a Java virtual machine. So distributed computing and parallel computing are often used in interchangeably. So parallel computing is So the parallel computing is typically used for high performance computing tasks, while distributed computing is ideal for scalable and fault tolerant systems. So that's the main significant difference of distributed computing and parallel computing. So you can see in the parallel computing, the processors access shared memory. So in the distributed computing, you can see processors usually have their own private or distributed memory. So you can clearly distinguish the difference between the parallel versus distributed computing from these two diagrams. So when it comes to distributed computing benefits, as I mentioned earlier, it supports scalability and modular growth. And also it supports fault tolerance and redundancy. So when it comes to Spark benefits, so Spark utilizes the power of distributed computing. So it supports a computing framework for large-scale data processing and analysis. So provides and also it provides parallel and distributed processing, as I mentioned in the previous slide as well. So it provides scalability, fault tolerance on commodity hardware. So fault tolerance means the system's ability to continue operating properly even when some of its components fail. So that ensures high availability and business continuity. So when it comes to running real-world production systems, it is important to have this fault tolerance capability. And also Spark provides speed due to its in-memory processing. So it is one of the unique features of Spark, and it creates a comprehensive unified framework to manage big data processing. So you can see how data processing take place in a unified framework in the diagram as well. And it offers you the flexibility to use with Python. So for Python, we have PySpark, and if we need to code pure Spark, we can use Scala. And also it supports Java APIs as well. So if we compare Apache Spark and MapReduce, so in the traditional approach, what we saw was it creates MapReduce jobs for complex tasks. Interactive queries and online event hub processing involves significant amount of flow displays. So as this diagram depicts, it says how in Hadoop it read from its distributed file systems, and it involves several read and write requests. So this results in slow disk input output. So that's where Spark have come up with a solution that is keeping more data in memory. So this has enabled to access data quite frequently instead of accessing it from a disk. So you can see in the diagram as well, zero read-write disk bottlenecks because of keeping data in memory. So that's the most significant advantage of Apache Spark, having in-memory storing data in memory. So Spark and big data, we can see there are so many versatile components in Spark. When it comes to data engineering, we utilize this core Spark engine, and we have clusters and executors, and we have cluster management capabilities, and we have Spark SQL, Catalyst, Tungsten, data frames. And Tungsten is a project within Apache Spark actually, so it is aimed at optimizing execution by improving CPU and memory efficiency. So this Tungsten project enhances Spark performance by reducing Java virtual machine overhead, leveraging cache computations, and using whole stage code generations. So when it comes to data science and machine learning, we have these important components of Spark, Spark ML, and data frames and streaming capability. So here you go again, an AI in action.
There are hundreds of millions of acres of forest in the United States. What's happening with them today is the result of centuries of past decision making. Forests are made up of complex interconnected systems, and there's never been a way to measure all of these systems. And you can't manage what you can't measure. Through Microsoft's AI for Good initiative, we created the first high-resolution inventory of all U.S. forests to provide better data and to make better decisions.
We've been timbering this land for over 40 years. The watershed provides drinking water to all the citizens of Duncannon. It is not maintained in a sustainable way.
Duncannon came to the Nature Conservancy because they had no forest management plan. Using Sylvia Terra, the borough will know how many trees are per acre, waterways will be mapped and buffered. This will be sustainably managed working forest forever.
Working with Microsoft AI has been transformative because it allows us to scale our process globally and to democratize access to this kind of information.
We have the forest that we have today. We can't change that. What we can change is the future.
Microsoft AI and Sylvia Terra are empowering landowners so they can grow the forests of the future. Every single person has a stake in this.
So that video shows how big data is impacting in environmental conservation initiatives. So when it comes to big data in action, we can't forget this planetary computer by Microsoft. So actually this planetary computer by Microsoft is a platform that lets users to leverage the power of cloud to accelerate environmental sustainability and earth science. So this planetary computer consists of four major components: data catalog, API, hub, and applications. So this data catalog includes petabytes of data about Earth systems, and it is hosted in Azure. And it is freely available for users. And the API allows users to search for the data they need across space and time. And this hub component is a fully managed computing environment that allows scientists to process massive geospatial datasets. And when it comes to applications, applications are built by network of partners who have joined with this planetary computing initiative. They are working collaboratively to enhance the performance of this platform to environmental sustainability. So this planetary computer uses open source tools and supports open standards. So many of the planetary computer components are open source. So these provide guidance on how to tie together open source libraries on Azure for geospatial and environmental data analysis. So now let's discuss how big data integration and real world applications take place. So let's begin with understanding the data. So you can see this workflow. This is actually big data and predictive analytics processing workflow. So when it comes to understanding the data, it involves knowing our data sources, whether it's transactional systems, logs, or social media, and the format of data sources. Next, we introduce big data technologies like Hadoop, Spark, which helps us to process huge volumes of information efficiently. So then comes the data mining. So it comes to play where we uncover hidden patterns using techniques like clustering and classification. So text analytics is quite valuable when working with unstructured data. So it helps us in extracting meaning from sources like customer reviews and documents. And the analyze the data phase involves applying statistical tools to start delivering insights. So finally, we extract actionable insight that inform decisions and strategies to our business customers. So this is where actually the raw data transforms into business value. So if we shift our focus to predictive analytics, so it builds on process data to forecast future outcomes. So statistics help us to understand trends and relationships within historical data. And modeling takes further by creating algorithms such as regression models and neural networks. So those things can predict behaviors and risk. And deployment is where the models are integrated into real-world system. So for an example, we can identify recommendation engines where models are deployed and fraud detection platforms. So that's how this big data and predictive analytics workflow works. So this is actually a diagram that represents comprehensive view of the data life cycle. So at the beginning of this session as well, I briefly presented a high-level overview. So this is a bit in detail. So we have this data life cycle from ingestion to access, encompassing key layers like security, governance, and intelligence. So at the foundation, we have data security, governance, metadata sets, quality, and lineage. So these elements ensure that our data is trustworthy, traceable, and well managed across the pipeline. So data enters the system through this ingestion layer, which includes both on-premises and cloud sources. So technologies here enable streaming data movement and even machine learning during ingestion. Next, the processing and persistent layer leverages frameworks like Hadoop and Spark. So those are core analytic engines that handle distributed processing and massive data volumes. Then we have the orchestration layer that enables transformation, integration, and cleansing. So that means preparing data for downstream use. So this coordinates the processes across system and ensures consistency. Then comes the data discovery. So where we in this data discovery stage, we model, curate, and virtualize data. So this is crucial for preparing data in formats suited for analysis and decision making. So finally, in the access layer, it delivers data through mechanisms like in-memory computing, caching, embedded access, and self-service tools. So this empowers end users with applications to extract value seamlessly. So altogether, this ecosystem supports intelligent decision making, scalable data operations, and advanced analytics. So that's how this end-to-end workflow supports. So this is actually a similar workflow, how big data is used in climate change studies. So you can see this flowchart outlines how starting from raw observations and it is ending in real world impact. So we begin at the top. The process starts with observing and monitoring climate data. That means through satellite sensors and environmental logs. Then next we have understanding where scientists interpret this data to learn about patterns, forces and interaction within the climate system. And then using analytical models and simulations, we move into predicting future climatic scenarios like temperature changes and rising sea levels. So final top layer goal is optimizing, using insight to improve intervention policies and climate resilience strategies. So in order to enable this process, big data brings together resources like environmental databases. So I mentioned that parallel compute, that is a good example. And we apply big data analytics techniques, including AI, machine learning, and statistical methods to make sense of large, complex datasets. So this creates scientific and practical value across disciplines. So this fuels new research and actionable insight. So this big data application extends to areas such as energy efficiency and intelligence, and it supports sustainable energy planning. And when it comes to smart farming and forestry, this data helps to optimize crop yields, soil health, and forest conservation. And when it comes to planning and infrastructure, so the data guides design and resource allocations, supporting planning city infrastructures. And we also see impacts in natural disaster and disease assessment, where predictive analytics improves response readiness and mitigation. And finally, advanced support like policy modeling, early warning systems, and educational platforms all stem from big data insights. So that is the major important aspects of big data. This is also such a workflow, so I'm not going to explain in detail here. So when it comes to real world use cases, so we see e-commerce recommendation system, fraud detection. When it comes to finance sector, we have risk management and algorithmic trading. And when it comes to social media, we can identify big data is used in sentiment analysis and trend detection. And also in logistics, big data is and AI is widely used in supply chain optimization and predictive maintenance. So now let's dive into Azure Big Data landscape. So this is actually a big data architecture in Azure. So a big data architecture is actually designed to handle the ingestion, processing, and analysis of data that is too large or complex for traditional database systems. So this is the high level overview of a big data architecture. We have data sources and we have data storage, real-time asset ingestions, and when it comes to processing, we have batch processing or stream processing. When it comes to analytics, we have analytical data store, and we have then analytics and reporting. And to carry out this every process, we have orchestration. So this is simply a high level overview of big data architecture. So when we consider about the big data workloads, we have batch processing of big data, sources at rest, and we have real-time processing of big data in motion, and we have this workload of interactive exploration of big data, and we have predictive analytics and machine learning on big data. So if we consider this big data architecture, we can identify several components as I showed you in this diagram. So when it comes to data sources, we have application data sources like relational or SQL databases, and we have static files produced by applications like web server log files, and we have real-time data sources like data from IoT devices. So when it comes to Azure, we have these Azure offerings. When it comes to data source layer, we have Azure Data Factory. So it is used for connecting to various sources on-prem and cloud. And then we have Azure Data Lake Storage Generation 2. So this is also a major data source in the Azure Big Data offerings. And then we have Azure SQL Database and Cosmos DB. So if we are sourcing from structured cloud database, we have these offerings. So when it comes to the next component, we have data storage. So data for batch processing operations is typically stored in a distributed file store. So this distributed file store can hold high volumes of large files in various formats. So this kind of store is often called a data lake. So options for implementing this storage includes Azure Data Lake Storage Generation 2, and we have Azure blob containers in Azure Storage. So those are the Azure offerings for this data storage component. Then when it comes to batch processing component, we need this batch processing because the datasets are so large. So often these big data solutions must process data files using long-running batch jobs in order to filter, aggregate, and prepare this data for further analysis. So usually these jobs involve reading source files, processing them, and writing them into output files. So in Azure, to process large volumes of data at intervals, we have Azure Data Factory for orchestration and scheduling these batch pipelines, and we have Azure Batch for high performance computing tasks, and then we have this processing engine, Azure Databricks. So if we need to use Spark based batch processing, we can use Azure Databricks. So when it comes to real-time asset ingestion, we have to handle incoming streaming data. So for this, we have these Azure offerings. We have these Azure offerings like Azure Event Hubs. So Azure Event Hub is widely used for telemetry and event data at scale. And we have Azure IoT Hub for ingesting device data. And we have Azure Service Bus when messaging patterns like queues and topics. And then we comes to streaming processing component. So it processes and transforms real-time data. So for this, in Azure, we have Azure Stream Analytics. So it is quite easy to use SQL-like streaming processing. And then we have Azure Databricks for structured streaming. So this is actually a Spark-based real-time data manipulation platform. And then we have Apache Flink on Azure HD Insight. So we can utilize this for advanced event processing. So this is quite powerful. Then we have analytical data store component. So this basically stores, clean and transform data for analysis. So for that, we have these Azure offerings, Azure Synapse Analytics. Azure Synapse Analytics is a unified warehouse with powerful SQL and Spark engines. And then we have Azure SQL database and Azure SQL data warehouse. So we can store data for structured and analytical queries. Then we have our CosmoDB, which we can use as an analytical store for NoSQL analytical queries. So likewise, when it comes to analysis and reporting component, we have several Azure tools to explore and visualize insights. So Power BI is a popular tool. So we can use Power BI to create interactive dashboards and reports. And also we have Azure Analysis Services. So this is an enterprise-grade semantic data modeling service. And then we have this Microsoft Fabric, which is an unified data platform, which we can use for unified data analytics. So when it comes to orchestration component, it basically manages and coordinates the flow between all these other components. So when it comes to Azure offerings, we have Azure Data Factory. So this is the primary orchestrator for data workflows in Azure. And then we have Azure Logic Apps. So this Azure Logic Apps is widely used for event-driven low-code automations. And then we have the Azure Synapse pipelines, the go-to analytic tool for orchestration built into Synapse Studio. So that's how Azure offers several services for big data. So before wrapping up today's session, I need to discuss about how we can get started with Azure Big Data Landscape. So first and foremost, we have to understand key concept. So we have to gain a good understanding on distributed computing and batch and streaming processing, as well as we have to get a good understanding on the storage layers and the storage formats and the types of data, as well as we have to consider the Azure architecture patterns like Lambda and Medallion. And in order to get started on Azure, we have to have a Microsoft Azure account and a subscription. So we can use Azure Portal, Azure CLI, and VS Code with Azure extension to integrate those Azure services in our development. So we have to set up resource groups and region preferences as well. So we have so many Azure offerings. So as I explained earlier also, there are several layers in this big data architecture. So we have for ingestion layer, we have this Data Factory, Event Hub, and IoT Hub Azure offerings. And for the storage layer, we have Blob Storage and Data Lake Gen 2. And for the processing, we have Synapse Databricks, Stream Analytics, and HD Insight. And for the orchestration layer, we have Data Factory, Synapse Pipelines, Logic Apps. And for the visualization, we have Power BI, Fabric, and Analysis services. So we have so many services, core services, so we have to pick the ideal service for our use case. So today, if you need to learn more about big data, now you have access to so many resources now. So you can utilize Azure free credits and to get hands-on experience and to run big data workloads. And also you have so many learning paths in Microsoft Learn and other course platform as well. So go and try to grab that knowledge and get hands-on experience from the free offerings. So this is how big data have evolved through the past years. So we can see exponential growth in big data. So this is actually a report from McKinsey report, which depicts the digital era data growth and estimates and Gartner IDC estimates. So it is expected by 2025 how massively the data landscape is evolving. And also when it comes to fastest growing and declining jobs by 2030, we can see this big data specialist is the fastest growing job. So it is actually one of the demanding job in the coming years. So however, when it comes to big data, we have quite a lot of challenges. So we are lacking data talent and skills. So we need good data in order to process them and derive valuable insight. And also we have to cope up with the speed of the data growth. So day by day we are getting massive volumes of data. And also we have the problems with the data quality and the compliance violations when it comes to regulatory bodies and the integration and complexity in integrating these big data workloads in production environments, and we have security concerns. So those are the major challenges we come across when it comes to big data landscape. To wrap up today's session, so I will walk you through this final video as well.
Like never before, our world is changing. Faced with some of our most critical challenges, human ingenuity triumphs. Today, the Microsoft AI for Good initiative enables a person with an idea to accelerate it, to give it scale, to create change for the better.
Microsoft AI will help our work by empowering people to take action.
Through AI for Earth, photos can now help save a species. With AI for accessibility, the visual world becomes an audible experience.
Sanitary and peanut butter.
And with AI for humanitarian action, first responders can target their efforts faster than ever before.
It feels humbling to know that I'm actually helping another human being.
Today, we are empowering others to forge new paths, to fight famine before a crisis strikes, and protect ecosystems by identifying forests down to a single tree.
We have the forest that we have today. We can't change that. What we can change is the future.
Microsoft AI is fueling some of the most passionate and creative people on our planet, with the help of citizen scientists, to make change, once thought impossible, real.
AI will know and understand and model based on the child interaction.
AI unleashes new possibilities to impact our world. And together, we're not just dreaming it, we're doing it.
So from that video also, you may have noticed, like never before, as young generation, we have so many challenges to face because of this climate change, rising population, and scarcity of natural resources, and etc. So many challenges. So, and also one of our primary need, pure drinking water, is expected to be run out in 2050. So today we have the technology like never before. So all we have to do is to use this available technology to pursue new dimension to solve these challenges we come across. So it is quite important for us to use this all these cutting edge technologies like AI for good. So as the final remarks for my session, I would like to highlight this quote from Satya Nadella: "The future we will make is a choice we make." So today we have the technology to empower everyone to achieve more. So artificial intelligence is beginning to have an impact on the lives of people. So it has offered us unlimited opportunities to pursue untouched areas. So, and also it is growing day by day, and also it brings us so many challenges. So there are still so much out there to be done. So as technological enthusiast citizens and community, what we need to do is we have to use this technology for good. We have to leverage this technology for the betterment of people. So reminding that, I would like to conclude my session. So that's it. So thank you for joining me in this YouTube talk series. So may the data be with you. Thank you.
Thank you so much, sir, for that eye-opening and informative session. You have helped us to understand how big data powers AI and how this combination is shaping the future of technology, industries, and even society. Your experience, clarity, and encouragement have definitely sparked new curiosity in all of us. Before we conclude, we would like to present a small token of appreciation to Mr. Anjana Dodampe on behalf of the Microsoft Student Club of Wellassa University. Thank you again for being with us and generously sharing your time and insights with our community. To formally express our gratitude, I now invite Acting Vice President of MS Club, Tikshana Nirmal, to deliver the vote of thanks. Over to you.
Good evening, everyone. As we come to the end of this INNOVATE X session, it's my honor to deliver the vote of thanks on behalf of the Microsoft Student Club of Wellassa University and our INNOVATE X organizing team. First of all, a heartfelt thank you to our guest speaker, Mr. Anjana Dodampe, Senior Software Engineer at London Stock Exchange Group, for sharing his valuable time and insight with us today. Sir, your session opened our minds to the fascinating world of big data in the era of AI. You helped us understand how vast datasets are leveraged to drive intelligent systems, and you made it both insightful and engaging. Thank you for showing us the power of data in shaping the future of AI and for inspiring us to explore its real world application. We are truly grateful for your expertise, your innovative contribution, and the way you encourage us to think critically and boldly in the vast evolving field. A big thank you also goes to our amazing organizing committee and everyone who worked behind the scenes. Your dedication and teamwork are what make Innovate X a success. To everyone who will watch this session via YouTube, thank you for being a part of our journey. We hope this session sparked curiosity and encourage you to explore more in the world of AI and big data. We have more exciting tech topics lined up in our future sessions, so don't miss out. Be sure to join our WhatsApp community and subscribe to the MS Club of Wellassa University YouTube channel to stay connected and updated on all our upcoming events. Thank you once again for being part of Innovate X. We hope to see you in the next session. Thank you.
Thank you very much for having me.
Thank you, Tikshana. And with that, we wrap up tonight's session, Big Data in the Age of AI. A heartfelt thanks once again to Mr. Anjana Dodampe, to our organizing team, and all of you who joined us this evening. If you have more questions or would like to connect, feel free to reach out via our club channels. Until we meet again, stay curious, keep exploring, and keep building. Have a great night, everyone.